Hi, brief calculus students. When we're trying to integrate and substitute when we have natural logs, we can look at how the derivatives of log functions went. So previously we had the derivative of the natural log of x equals 1 over x, and we drew it this way, 1 over x, just in this first quadrant, even though it does exist over here. Since the natural log doesn't exist in this quadrant over here, then we just kind of restrict this 1 over x. So we're going to antiderivative, or take the integration of 1 over x, and x can't be equal to 0, and when we do this we say that it has to have an absolute value because it's not defined over here for negative numbers. So using this, the fundamental calculus says if we know that the indefinite integral is a function, then when we get limits on our integration, make it a definite integral, we just put in the function at the upper limit minus the function at the lower limit. And right here, b is the upper limit, it's on the top, a is the lower limit, it's on the bottom. So using this, the fundamental theorem of calculus says, let's say we take the definite integral from 1 to 10 of 1 over x dx. It should equal natural log of 10 minus natural log of 1. So I put 1 over x in the calculator and I go, let me do it the wrong way first. Zoom 4, just so I can see it. See how it does exist on this quadrant right here, this third quadrant, but we only use the positive one. Now when I want to go to calc, and number 7, I've got a lower limit of 1 and upper limit of 10. It's going to give me an error message because, let's see if I can make it go to. This upper limit isn't on the graph. So I have to change it to, let me do the windows, down to say 11 graph. Okay, now it will like it. Calc 7, lower limit 1, upper limit 10, fills it in. The area under the curve is 2.303. If I go to natural log of 10 minus natural log of 1, I get 2.303. So the fundamental theorem of calculus says, look, they're the same. It's just, this is our definition. This is our fundamental theorem. So a couple of examples. 3 over x is just 3 times 1 over x dx. Constants can be multiplied outside or inside. We get 3 times natural log of the absolute value of x plus c. We've got 2/5, and then we've got the 2. Well, the integral of 2 dx is just 2x. And this one right here, the 2/5 comes out as multiplication. We're just going to get the natural log of the absolute value of x. And don't forget the c. If you have pi in here, don't freak out. Pi is a number. It's just, this is the shortcut way of writing it, just like e is a number. So we just say pi times 5, natural log of x. And when I first wrote this, I wrote 3x squared, and I went, wait a minute. If I have a power of 2, I have to divide by 2 as well. Okay, plus c. So previously, we're looking at this stuff with log base b and a, and we got this complicated looking thing. So is this sort of, do we have to come back to the log base b? No, because the natural log of 3 is a number, and 2 is a number, and the 3 right here in front of the x is a number. We just have 1 over x dx. So let me move the screen down a little. So it's just, I could probably divide that 3 out. Oh, that's supposed to be a 2. Haha, you didn't see it. 2 divided by 3 times the natural log of 3 times the natural log of absolute value of x plus c. Okay, basic rules for taking the indefinite integral with natural logs. But we're going to use substitution, and the substitution comes in when we have a fraction that has functions in the integral. And the denominator is more complicated than what's on top, and the top looks like a derivative of the bottom. So here we have a fraction that has functions. The higher power is on the bottom, so that makes it more complicated. And it looks like we've got derivatives going on. So, step 1, we just say u is whatever's in the bottom. Step 2, we find the derivative of what u is. And we can rewrite this so that it has the dx on one side and du on the other. It's a notation thing. And this looks exactly like what we have on the top, so we're good to go. Substitute in what u and du are. And we know the definition right here, right? 1 over u du is the natural log of absolute value of u plus c. So we substitute the function back in for u. So I just kind of move it in. And then finally put a box around it because you're done. You did a good job. Another example. We've got the higher power on the bottom, two functions, fraction, and it looks like the top might be the derivative. So we'll let u equal the function on the bottom. We take its derivative, looking familiar. We kind of separate this out. So we can just throw in du for this piece right here, dx. That'll give us the indefinite integral of du divided by u, which is the natural log of the absolute value of u plus c. And then we're going to put that, whatever u is, back in. We put a box around it, we're done. This last example comes from your homework. We have the higher power on the bottom, and I'm not so sure the top is a derivative. So we let u equal the function on the bottom, take its derivative. Came out kind of cute, didn't it? So when we try to separate this, we get the dx. It's almost the same if we just factor out a 72. So how do we get rid of the 72? Well, you have to divide it on both sides. So if we divide the left side by 72, divide the right side by 72, looks like we get the exact piece that we need for the top. So this piece right here has to be 1 over 72 du. You can't leave this behind. And then the u just goes right there in the bottom. Then we get 1 over 72 times 1 over u du, which is 1 over 72 times the natural log of u, absolute value of u plus c. And then we put u, substitute with the u, and get 1 over 72 natural log of 8x to the 9th power minus 9x to the 8th power plus c. That c is not showing up inside the box, but that's it. We're done. Thank you.